To quickly review what we've seen so far, we have a charge plus QE in a massive proton, a charge negative QE at distance r, orbiting in a circular orbit. And again, this is not really what happens in an atom, but it's a model we're using right now. We have a mass which we call m sub e, and this mass is orbiting at velocity v and radius r. V and r are related. We can find the relationship by setting the Coulomb attraction between the two forces, between the two charges, equal to the centripetal force, which is equal to the mass times v squared over r. Solve that and get this relationship between v and r. And we expressed that before by taking out the 1 over square root of r over here and saying that what remains is a proportionality constant. Well, in any case, that gives us our relationship between v and r. Then we take our quantization condition that the angular momentum mvr equal nh bar, and we solve these two equations simultaneously. This solution is a little different than the one we saw before. What we do is we solve this equation for v. We get nh bar over mr, which is what we express here, and that's going to equal this expression for v. So we get the equation that we see here. We solve this equation for r, and we see that r has to equal n squared h bar squared over k qe squared me. There's our symbolic solution for the radius of the nth Bohr orbit. There's something really cockeyed here. Let's see if we can straighten this out a little bit. Okay. Now the radius being equal to what it is, and this is simply a rearrangement where we factored out the n squared. Again, we substitute the numbers for these quantities here, these numbers that we've measured and know very well, and we get our n squared times 0.529 angstroms. And we're doing a little calculation on units here that isn't really part of what we see here. This is simply the calculation we do on units to show that the units of this calculation here come out to be meters. Okay? And I'm not going to go through the details of that calculation, just alert you to the fact that you need to go through the details of the units here, and you'll see that the units come out to be meters. Now, if r is equal to this quantity, mvr equal to this, remember we get v equal to this, and so forth. Okay, we have our expression for v, we have our expression for r. Then the kinetic energy is 1/2 mev squared, and if we just put in this expression for v and do the algebra, we see that the kinetic energy is equal to this expression. 1/2 mek squared qe to the 4th over n squared h squared, h bar squared. The potential energy is negative k qe squared over r, as we saw earlier. And if we plug in this expression for r here and do the algebra, we end up with this. Notice that this expression has all the same factors that this one does, except this one has a 1/2 and this one has a negative 1 for coefficients. Then the kinetic energy, final expression here, potential energy, final expression here, we see that the kinetic energy does indeed have half the magnitude of the potential energy, but the potential energy is negative, kinetic energy is positive. We conclude that the total energy is what we get when we add the potential and kinetic, which is going to be the negative of the expression we had for the kinetic, or if you prefer, half the expression we had for the potential. And we factor out the n squared here, and we end up with this factor here. And we have -1 over n squared times this factor, plugging in the values of m, e, k, q, e, and h bar, and doing the unit calculation. We find that this factor here is nothing but 13.6 electron volts. Now to review what electron volts are. An electron volt is the energy that an electron would attain if it was allowed to fall freely from rest through a 1 volt potential difference. Okay? So the electron volt is just charge of the electron times 1 volt. Remember, charge of the electron is 1.6 times 10 to the negative 19th coulombs. A volt is a joule per coulomb. If we multiply 1.6 times 10 to the negative 19th coulombs by 1 joule per coulomb, we end up with 1.6 times 10 to the negative 19th joules, and that's equivalent of the electron volt.